What is up? Hello and welcome to Unit 4, Part 1. All right, I'm going to do this in two parts. I think we'll go to number 9 first. Guys, I'm so tired. I'm dead, bro. I got to go home. I'm liking it. I think I have a time limit. I think I have 30 more minutes to do all of Unit 4. There's no way. There is no way, Chief. I don't think it's happening. We're going to try our best. As always, what else can you do? All right. This is the picture I drew for you guys today is me when you when I see the test answers. Yeah, no way. Okay, given the first two sides of a triangle, use the triangle inequality theorem to find the range of possible third side C. What is it? What's with this package? All these questions sound so funny. Okay, given the first two sides of a triangle, use the triangle inequality theorem to find the range of possible third side. I think it means possible values for the third side. The range of possible values for the third side, okay? So, let's see here. So you have a triangle. You're trying to make a triangle. You have two strings. One is 9 feet, one is 14 feet. If I give you a roll of string, how long can the third one be and still make a triangle? Right? What's the possible ranges you could cut it at? All right? Now, I ask students to try this out, like on their own. Cut out a string. I mean, not literally, but like figuratively. Cut out a string. Let's see here. Just to show you I'm not cheating. All right? Let's cut out a string. And let's say it's 15 feet, okay? If I cut out a 15-foot string, 15, I need 9 plus 14 to be more than 15. Sure enough, 9 plus 14 is more than 15. So 15 would work. That is one possible value. Then you could keep asking, like, well, what about 13? Well, I need 9 plus 13 to be more than 14. And sure enough, it is, right? So you keep going. Anyways, it works out that the most you could have, like if you added 9 and 14 and got 23, then C needs to be anything less than 23. Because if you add 9 and 14 to get 23, then that's the most you could ever make. The least you could ever make is if you used a different number plus 9 to get 14. So like 4, like what number do we need to get 14 with 9? What number do you add to 9 to get 14 is what I mean to say. And that is 5. It has to be more than 5 to make sure that we get 14, which is the longest out of 9 and 14. Okay? So essentially, what you do is you add them to get the big one, and you subtract them to get the small one. Alrighty? So here, 21 and 16 together, that's the highest possible value is 37. Lots of 37s in this packet as well. And then 21 minus 16, we need to go, and here's a little trick for you. We need to go 4 up from that, so it must be 5. I don't know if you guys know how to do that. What am I doing? Making 10s, I guess? I'm not going to show that right now. All right, 21 minus 16 is 5, right? C, here we have 6 and 4. 6 and 4 together is 10, so it's got to be less than 10. And I should be using my units here. This is feet. Alrighty, 21, this is miles. Alrighty, and 10, this is 10 inches. And then here we have 6 inches. It's got to be less. 6 minus 4 is 2 inches. God, I'm in the entire now. I'm starting to make more mistakes. Alrighty. Anyways, we can keep going here. That is the triangle inequality summed up. If an isosceles triangle has 10 oh my god. An isosceles triangle has sides 10 inches and 20 inches. What is the length of the third side? A lot of students told me this is impossible, that there's 2 possible answers, Mr. Shirley. Actually, it could be anything. I don't think you understand this problem. This triangle, we know a lot about it. It's isosceles, which means 2 of its sides are equal. All right, so this triangle looks like this. 2 of its sides are equal. So let me draw that more down here, actually. Alrighty, and we know that it has sides 10 inches and 20 inches. So let's say there's 2 options, right? If this is 10 and this is 20, right? Then this side would also have to be 10. But 10 plus 10 is not more than 20. It's equal to 20. Right? It's not more than. So it doesn't work. This is impossible. So the only other option is that the sides are 20, 20, and 10. In this case, 20 plus 10 is 30 either way. So they both fail. They both work. This is a triangle. 10, 10, and 20 is just a straight line. Right? 10, 10, and then 20 all the way across. Anyways, so for number 3, list the angles of the triangle from smallest to largest. Yes, sir. So for this one, here we see the angle 9 is the angle 9 is the width of the side is very big. 9 is bigger than 7 and 8. So that means the angle J has to be wider to fit all of 9 in there. So if angle J is fitting 9, then it has to be the biggest, which means J goes last in this case. Alrighty. And then here, our next up number is 8. So that means H, which is fitting 8, has to be more than 7, which is G. So that means angle H will go here, and then G will go here. So GHJ is the correct order for these. Alrighty. This is called angle relationships. We also use something similar to it called hinge theorem, if you want to Google it. Alrighty. It's very common sense if you see it in action. Basically, the wider your mouth, the farther your teeth are apart. The more open your hands are, right, the farther your fingertips are apart. That's all hinge theorem is trying to say. All right, so we'll keep going. Use the figure to find the measure of angle CAB. CAB is this angle. That is what I'm looking for. This angle is supplementary to 14x minus 7. It is also supplementary to the sum of these two angles. All right. What I could do here is use the exterior angle theorem to find the value of x, and then I will plug it in, solve that over here. So before I even start a problem, I haven't written anything. I'm thinking of something I can try. It may not work. Like, it may not be the best idea. It may not be the most efficient or fastest method, but I'm thinking of something to try, right? I am going to try setting this plus this equal to this by the triangle exterior angle theorem. Alrighty? So this is supplementary to this. These two angles are also supplementary to this. So that means they must be the same. 7x minus 6 plus 48 is equal to, and then this is 14x minus 7. I'll now get a value for x, and then I can use that value for x to plug in for 14x minus 7. So what I get here, 7x minus 6, I'm going to do my like terms. Let's see. I'm going to subtract 7x from both sides. I see negative 6 and 48. That gives me 42. I'm going to add 7 to 42 to get 49, which is equal to 7x. And so x must be 7. Alrighty. Now that x is 7, I'm going to back substitute it. 14 times 7 minus 7. Let's see. That is 70 plus 28, which is 98 minus 7 is 90. 91. I don't know what's so hard for me. 91. Is that correct? Let's see here. 14 times 7. I have a little bit of doubt in my head. Yes, 91. Okay. So 91 is this angle. So that means the rest has to make up for that. So this must be 99 degrees, right? That is because 180 minus 91 is 89. Oh my gosh, yes, of course, 89. I'm insane. Good thing we checked. Alrighty? Too tired to be making these kinds of mistakes. Is equal to 89. Very nice. So the measure of angle CAB is equal to 89. Maybe just to be very clear for the reader, I'm going to write CAB is equal to 89 degrees. Okay. I'm going to keep going. I'm grinding here, trying to go as fast as I can so I can do all my errands I got to do, bro. I got to go before the date closes, guys. CG, EH, and FJ are mid-segments of triangle ABD, GCD, HEG, HGE, respectively. So what they're saying is CG, this guy, is halfway of the big triangle, right? That's ABD. Then it says GCD is cut in half by EH. So EH cuts this guy in half. And then it says FJ cuts this guy in half. All right? So we want to find all the measures of all these angles. I believe this is at 22. So I'm going to write 22 here. Okay? First, I know that the midsegments are parallel. So I see that it wants me to find the measure of angle CG, or CG. I know that CG must be half of 33, which is a 17.5, right? Yes. 17.5, so that's CG. All right. Then for EH, oh, this is 22. Excuse me, I'm so silly. This is 22. This is the midpoint, so this is also 22. I'm crazy. All right, these are the same. And then, since this is 22, half of that is 11. All right. For FJ, I see that this has to be half of 17.5, which is 8 point... Wait. Yeah. 8. It needs to be 0.5 to get 17. 0.325. Oh, no, I made a mistake. It needs to be essentially 6/8. That's my bad. 3/4. Oh, 7/5. Of course. What am I thinking? Thinking in eighths. 8.75. I'm sorry, guys. I'm losing my mind, bro. I'm just so tired now. My math is not mathing. So, the measure of angle GHE, which is this guy, well, this is corresponding to this angle, which is corresponding to this angle, so it must be 57 degrees, right? The measure of angle DCG, I see that is here. That's also the same. I don't know why that would give me that after that, okay? And the measure of angle FJH is also 57 degrees because it also corresponds. Very nice. Look at that. So that's because all midsegments are parallel. And we're going to keep going. Oh, oops, wrong page. All right, this is the last page for Unit 4, Part 1. Then we'll do Unit 4, Part 2 if we got time. L is the centroid of the triangle MNO. ML is equal to 10. LN is equal to 8. And P is equal to 11. So I'm going to first draw all these in. ML, that is 10. Oh, it's already drawn it for me. Oh, lovely. Okay, so if this is the centroid, you're going to have to remember the centroid rule, which says that all medians are cut into a 2-to-1 ratio. The centroid is constructed by medians, so since L is the centroid, all these lines must be medians. Therefore, these are all midpoints, right? I guess I should use 3 tick marks there. Beautiful. So for the measure of angle for the measure of the segment OP, that's here. It has to be 11. This is because it is a midpoint for both sides. And for the measure of angle LP, I see that ML is made up of 10. So I'm going to draw it like this. So here is MLP, the segment. All right. Here, this guy, what the 2-to-1 ratio says that the centroid L cuts this segment MP not into 2, but into 3 equal parts, where 2 of those parts are on this side. So it's cut into a 2-to-1 ratio. Just like when you cook rice, you have a ratio of 2 cups of water to 1 cup of rice. Or is it the other way? No, it's definitely that way, right? 2 cups of water to 1 cup of rice, right? It's exactly like that. So over here, I have 10 in the 2-parter. So it wants to know how much is LP. Well, if 10 makes up 2 of these parts, then each part must be 5. That means the third part must also be 5, and so LP is 5. Alrighty? You could set up a proportion here if you wanted to. Like you could say, it would just be like 10 is to 2 parts as X is to 1 part. But you just end up doing the same thing anyways. Alrighty? We can keep going here. This is a beautiful example of a circumcenter. Notice that all the endpoints have been passed through by a circle whose center is inside the triangle. That shows this triangle is actually an acute triangle. And furthermore, it is the points that make these up are all perpendicular bisectors. So you can see they're all 90 degrees. And also, like, for example, FC and FA will be the same length because they're perpendicular bisectors. So it actually says that over here. Then it says CH is 13. So C to H is 13. Then it says CG is 12. Alrighty, let's see. Can I get CG here? CG is 12. So even though this is a very ugly picture, what it wants us to find first is BG. If you look, this is a long, skinny triangle where we had 13 on the top and 12 on the bottom. So to do this, we could do the Pythagorean theorem. This is A. So we'll say that A squared plus 12 squared is equal to 13 squared. We know that HG is a perpendicular bisector because H is the circumcenter of the circle. Therefore, using Pythagorean theorem here, we get A is equal to the square root of 13 squared minus 12 squared, which we find to be, 5. Should have known that, Pythagorean triple. So we get BG is 5. Very nice. All right, and then we also want to find BH. Well, if this is a circle, then that means H and C is the same distance from H to B because these are both radii of the circle. So we can put 13 safely for BH with no extra work required. All right, for the last one here, we have BG is equal to 10, BD is equal to 8. The picture we're looking at, these guys are all angle bisectors. That's what it's trying to show here. 1 tick mark indicating these angles are the same, 2 tick marks indicating these 2 angles are the same, and 3 tick marks indicating these 2 angles are the same. So the angle bisector forms the in-center of the circle, which means the circle that fits in here looks like this. It's obviously not drawn correctly because if this were correct, G would be perfectly in the middle here. So whoever made this did not make it perfectly, but that's okay. Don't panic, right? The beautiful thing about the in-center is that all of these lines to the walls will be the same length. So it says DG is equal to this. Well, if BG is given as 10 and BD is given as 8, this looks like another case of the Pythagorean theorem. So I'm going to redraw my triangle over here. I have this triangle. I have 8 on this side. 10 is the hypotenuse. So that means that if this side is A squared plus 8 squared is equal to 10 squared. So A must be equal to the square root of 10 squared minus 8 squared. Alrighty, 100 minus 64 is 36, so we know that A is going to be 6, and then we will put 6 here. Very nice. That is our length for DG, which you just saw for. I know I'm going fast, guys. I'm sorry. Please slow the video. Watch it again if you need to watch it again. I'm just in a huge rush now. GF is on this side here. I see that since this is the in-center, all these lengths must be the same, since the circle that fits inside here would be touching on all these points. So if the length we just found is 6, this one is also 6. Very nice. So in geometry, when in doubt, a repeat answer, it may be possible. You guys see that we've been, kind of reusing the numbers in the past. Anyways, that is all I have time for today. I'm going to try and do a Unit 4 Part 2 video when I get home. If these even upload to YouTube, who knows if you guys are even going to be able to see these. Oh my God. Imagine I wasted all this time. Anyways, without further ado, guys, I'm going to cut you loose. Here's my picture. To leave you with, it's going to be just a guy with a crazy haircut. No one in particular. Let me know if this looks like a friend of yours or maybe your mom or something. Alrighty, guys, there really is nothing else to do for this review. If you feel really comfortable with the current material so far, Unit 4 Part 2 is also going to be on there, so make sure you check those last few parts. If this is my last time talking to you guys. You need to make sure that you have looked on the Delta Math as well. That's also some good advice on there. There's good problems on there for you to work on. If you need to think a little bit deeper, Delta Math is great for giving you more options if I'm not around, right? It can help you, give you more videos, give you more practice problems, all that stuff that I would normally do. I don't know why I'm going to make him blush. That's kind of weird. It's kind of goofy. Also, I don't know why he looks like Minecraft Steve, low-key, but that's okay. Ladies and gentlemen, goodbye. I will see you guys soon.